Hey everyone! Today we are kicking off our probability chapter. This is chapter 7 in Algebra 2A. This first lesson covers a lot of the basics. We're going to talk some vocabulary, we're going to talk about just some foundational things they have to do with probability, and that's about it. And then we'll get into some more complex probability situations in future sections. So starting out, we've got some vocabulary here to work with, and if you'd like to pause the video to make sure you get that vocab copied down, you certainly may. But starting out just in general, when we're talking probability, an experiment is some sort of situation that has multiple possible results. And that can be a single trial or it can be made up of multiple trials. So I'm just going to throw out an example here. Our experiment could be as simple as rolling a die, like a single dice. And I'm going to just stick with that kind of analogy to give you some examples of some of these other words too. So if I roll a die, there's several possible outcomes. I could also design an experiment where I'm going to roll a die 10 times. Okay, so that would be multiple trials, but all in the same experiment. So the outcomes are those possible results, those different results that can happen. So if I'm sticking with the rolling a die example, my outcomes could be a 1, a 2, a 3, a 4, a 5, or a 6. And really, by listing all of those there, what I really just did is define what's called the sample space. So the sample space is the set of all of those possible outcomes. So any one of these, like 1 or 2 or 3, those would all be considered individual outcomes. The sample space is when I list all of the outcomes there. And then the event is an outcome or a group of outcomes that meet a certain condition that we're looking for. And that's where probability is going to kind of play in. So for example, I could have an event of rolling a shoe. And there's only one possible outcome in that event, right? Would be rolling a shoe. You could also have an outcome like rolling an even number. And so there's like a whole set of outcomes then. It could be a 2, a 4, or a 6, and that event would have occurred. Okay, so events are the individual things that can happen, but you can group together outcomes to make an event. So let's practice using that vocabulary a little bit. A test is being scored using letter grades, so let's give the sample space. Sample space is, again, all of the possible outcomes. So you take a test and you know that I'm going to slap a letter grade on it before I give it back to you. What are all the possibilities you could get? And we're just going to, for simplicity's sake, we're going to assume that these are like clean letter grades. So my sample space would be A, B, C, D, and E. Those are the 5 possibilities you could get. So then the event passing would be which of those outcomes would be part of what we would call passing. And so for us, passing would be A, B, C, or D. Okay, so it excludes the E because that's not passing. Okay, so just in general, when we're talking probability, anytime I'm asking you to find the probability of something, it's a fraction or it's a ratio of some kind. Okay, remember, fractions can be written lots of different ways. They can be written as fractions, they can be written as decimals, they can be written as percentages. We're going to be working with all 3 in this unit. So in general, probability always comes from the number of favorable outcomes divided by number of total outcomes. So this is a little unrealistic, but just stick with me here for a second. Just as an example of these 2 terms here, using this example up above, let's suppose I was grading your test totally randomly. I was using like a random letter generator. I was pulling grades out of a hat. So your test lands in front of me and I'm going to just pick one of these 5 cards out and say, oh, so-and-so gets a C today. So-and-so gets a D today. So you can just get any random letter grade. If I want to know what's the probability of me passing, I would say the number of favorable outcomes, which would be 4, out of the total number of outcomes, which would be 5. So the probability of passing, if I just assign a random letter grade, would be 4 out of 5. We know that grading is not random, so that doesn't really apply. But again, just to kind of get you used to those words. And then one more term that you should know. Mathematically, the definition of fairness is when all of the outcomes are equally likely. So, in this event that I just described, if I was randomly drawing these letters and all 5 letters were equally likely, technically we would call that fair because everybody has the same chance. Obviously, in terms of grading, I don't know that I would really call that fair, but mathematically, we would say that that's fair. Or rolling a die. It's fair because all 6 of these outcomes are equally likely. Now, if you were going to challenge like a younger brother or sister and you say, I'll tell you what, we're going to roll this die, and if it's something under 5, I win, and if it's something above 5, you win, that's not fair because doing 5 or under is not equally likely with doing anything above 5, which would really just be a 6. So that's the idea of fairness, is making sure that you have equally likely sets of outcomes. Okay. A couple more things here. So in this one, we're going to look at rolling 2 dice, and you're going to be doing lots of these 2 dice probability problems here. So I printed you out a sheet here. I'm going to just slide this camera up. Sorry for the arm close up there. I just wanted you to be able to see it. But this sheet here gives you a visual of all the different ways you can roll 2 dice, okay, and what combinations you can get. And so the first question says, what are the total number of outcomes in the sample space? So you can get 6 different things rolling that first dice and 6 different things on the second. And so altogether, that makes for 36 combinations. We're going to learn more about why that's true later on, but it comes from doing 6 times 6, so there are 36 possibilities. We can see that in our picture here. If you counted these up, there's 36. Okay, the outcomes of the event rolling doubles. So doubles is when you roll 2 of the same. So that would be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So the outcomes would be exactly what I just said. Okay, so that's how we would list the outcomes. That's the set of all possibilities that would fit this situation. Okay, so now we're going to actually do some probabilities. And remember, probability is always designed as a fraction out of the total number of possibilities. So for all of these situations, that 36 is going to be my denominator. This is going to be something out of 36. This will be something out of 36. And this will be something out of 36. Our job is just to figure out what out of 36 it is. So rolling a sum that's less than 4. So we're adding our 2 dice together and seeing how many could we do that are less than 4. You may be able to write these out without using a sheet, but just so you have the visual, that would make a sum of 2, right? 1 and 1. 2 and 1 makes a sum of 3. 3 and 1 makes a sum of 4, and we need to stay strictly under 4, so that one doesn't count. And then we know all of these are going to be higher because all of these have a first die that's bigger than 4. So now let's look at this. 1 and 2, that makes 3. That one's okay. But 2 and 2, you're already at 4. And again, all of these are also going to be higher. Here, I'm already at 4. And so all of these are going to get larger because the sums get larger as you go down the list. And then here, we're starting out at 5. So again, we know that all of these are going to be bigger. So I really only have these 3. So I could say my probability is 3 out of 36. Now, I'm going to leave this as a fraction, but I am going to take that 3 out of 36 and reduce it. And if you need to use your calculator to help you, you can. But 3 out of 36 is equal to 1 over 12. You could also do 1 divided by 12 and turn that into a decimal, or you could even turn that decimal into a percentage. Okay, rolling a sum that's exactly equal to 7. All right, let me get rid of my little pink stars here. And let's start looking for the 7s. So in this row with the 1, I can make a 7 way down here with 6 and 1. This row with the 2s for my second die, I know I can do that with 2 and 5, so that's here. You're going to see a pattern pretty quick here. This row has, or I'm sorry, this column has all 3s, so I'm looking for the 3 and the 4, that's here. Okay, here I have 4 and 3, that makes 7. Here I have 5 and 2, that makes 7. And here I have 1 and 6, that makes 7. So I counted 1, 2, 3, 4, 5, 6 ways to make 7. Okay, so that probability would be 6 out of 36, which is equal to 1 out of 6. Okay, what about a sum greater than 15? Okay, well, where can we get a sum greater than 15? Think about that for a second. And I hope you're thinking that that's a big fat nowhere, because way down here, the largest sum I can possibly get is 12. 2 6s would make a 12. There's no way to get a sum that's larger than 15. So we call that 0 out of 36, which is just a probability of 0. By the way, I should have mentioned this. Probability, because it's fractions and decimals, is always measured between 0 and 1. Again, we can express that as a percentage. So if you're living in the land of percents, that's like between 0% and 100%. But numerically, that's between 0 and 1. If you have a probability of 0, that means your event is impossible. Okay, it cannot happen. If you had a probability of 1, that would mean that you're guaranteed to have that happen. So if I had asked you about rolling a sum that's less than 15, because all of these sums are less than 15, we would call that 36 out of 36, and then that would be a probability of 1, meaning you're guaranteed to happen. Okay, one more example, no more dice here. Suppose a family has 2 children. List the sample space with boys and girls. Okay, well, let's start with, we could have a boy and a boy, right? Or we could have a girl and a girl. Or we could have the first child be a boy and the second child be a girl. Or we could have the first child be a girl and the second child be a boy. Okay. Another way to do this one was pretty easy because there was only 4, but we could have done this with what's called like a tree diagram. So we could have said, okay, here's my first child, and my first child can be a boy or a girl. And then my second child would come off of each of those. And my second child could be a boy or a girl, a boy or a girl. And so here's my combinations. Boy, 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 girl, girl, boy, girl, girl. So there's my sample space. What is the probability that both children are girls? So I'm looking for this particular outcome, which is right here, out of how many possible outcomes there are. So my probability would be 1 out of 4. Okay, there's a 1/4 probability that both children are girls. Okay, I think that's enough to get you started with probability. That really covers the basics and the vocab and all of that stuff. So you can go ahead and give the assignment for this section a try, and then we'll carry on with the next section shortly.